Next question is, consider the following system of equations in three variables x, y, z. We have minus x minus y minus z is equal to 3x plus y plus z is equal to 10, 2x minus 3y is equal to 6. Okay, we have to find out which of the following options is correct. The system has, first option is no combination of values x, y, z that satisfy this system simultaneously. Another option is only one combination value of x, y, z that satisfy this system simultaneously. Third option is only two combination of values of x, y, z that satisfy this system simultaneously. And fourth option is infinitely many combinations of values of x, y, z that satisfy this system simultaneously. Okay, so let's try to figure out what I have done. I have just rewritten these system of equations. Here I have multiplied the first equation by minus 1, so this becomes x plus y plus z is equal to minus 3. Then we have the same two other equations. Then I found out the coefficient matrix. That means I formed the matrix of the coefficients of x, y, and z. So the coefficient of x is 1, here also 1. The coefficient of x is here 2. So here we have 1 1 minus 3 1 1 minus 3 1 1 0. Okay, so in place of z, I have written here 0 times z, since no z is involved, so 0 into z is z. Sorry, 0 here. Okay, and this x is the solution vector that we need to find out the value of x, y, z, and b denotes the vector of constant terms. Now to find whether this system of equations has a solution or not, what we need to do, we will be using the Cramer's rule here. In Cramer's rule, first we need to find out the determinant of this coefficient matrix. How do we find determinant? We write this one, okay, and mentally delete this row and this column and take determinant of the remaining elements. So we have 1 zeros are 0, then we have minus, then minus in 3 into 1 is minus 3, so I can write it like this. So we have minus 3, then we have minus 1 from the formula. So mentally deleting this row and this column, taking determinant of the remaining elements. So we have 1 zeros are 0, then we have 2 ones are 2, plus 1. Okay, so first we have plus 1 minus 1 plus 1. Similarly, these change the signs alternatively. So deleting this row and this column, taking determinant of the remaining element, so we have minus 3 minus 2. Okay, so this comes out to be, we have 1 here, so minus minus is plus, we get here 3. Here minus 1 into minus 2 is plus 2. Okay, here we have minus 3 minus 2 is minus 5. So this comes out to be 0. We got determinant equal to 0. Okay, so if determinant is equal to 0, okay, so first we need to find the value of determinant. It came out to be 0. Then we need to find out the determinant of other elements, other what we call a1, a2, and a3. I explained this Cramer's rule in earlier video. You can check this also. For the detailed explanation, I will not be able to give the detailed explanation here. Now to find the a1, okay, that means to get the value of x, we need to form a new matrix a1 such that this a1 is formed by replacing this first column of the coefficient matrix with the vector of constant terms. Okay, so a1 will be formed by, so to find the value of x, just replace the first column with the coefficient of with the vector of constant terms. So we have here minus 3 10 6, and the remaining matrix will remain same, 1 1 minus 3 1 1 0. This is our a1. Similarly, to find the value of uh, y, what we need to do, we first need to find the value of a2. So to find the value of y, replace the second column this time. Okay, we form a new matrix in such a way that we replace second column with the vector of constant terms. So new matrix will be like this: 1 1 2. Then in place of this we write -3 10 6, and similarly we have 1 1 0 to get the value of what we call a2. Similarly, to find the value of z, we form new matrix a3 in such a way that in this case we replace third column with the vector of constant terms. So our new matrix will be 1 1 2 1 1 -3. In place of this 1 1 0 we write -3 10 6. Okay, now if I will write here, if any, what we can say here, if at least one of, that means a1 a2 and a3 is non-zero. Okay, if determinant is equal to 0, which is the case here, and if at least one of these a1 a2 a3 their determinant is non-zero, then we have no solution. Okay, but if a is 0 and determinant of this a1 is equal to a2 is equal to a3, if all the determinant of these is equal to 0, then we have infinitely many solutions. Okay, many solutions. Okay, now let us try to find out if any one of these is non-zero. Okay, so now let's take the determinant of this very a1 here. Okay, how do we find the determinant? Same process. First we write -3. Okay, mentally delete this row and this column and take determinant of the remaining elements. So 1 zeros are 0, then minus minus is plus, we get a 3. Okay, then we have -1, so -1. Now we need to mentally delete this row and this column and take determinant of remaining elements. So 10 zeros are 0, then we have -6, then we have +1, deleting this row, this column and taking determinant of remaining elements. So we have 10 threes are 30, so we have -30. Then we have -6 zeros, 6 ones are 6. So let us see what comes the determinant here. So 3 threes are 9, we get here -9. Here we have plus minus 1 into -6 is +6. Then we have -30 into -30 minus 6 is -36. Here we can easily see, we get here, this is 27, so 36 minus 6, so we get here, what we get here, we get here -30, so we get here -39, -39. Obviously a1 is not equal to 0. Okay, so we can safely say this system of equations has no solution. Okay, because we just took the determinant of a1, it came out to be non-zero. Okay, we need at least one of these a1 a2 a3 to be non-zero to get no solution. Okay, so we got that value of a is equal to 0. Okay, and one of these a1 a2 a3 at least is non-zero, which we saw here. So we can say no combination of values x y z that satisfy this system simultaneously. I guess this option should be right if I have done the calculation right. Otherwise, my calculation cannot be guaranteed at times.